Okay, here we go. This is my latest amp build. I call it the Ice Princess because it's supposed to be clean and cold, and it's a clean amplifier, not supposed to distort a lot. Jazz, blues, and pretty sounds. The design is off a website called AX84. They have quite a few different designs, and the forum is great. A lot of knowledgeable people helping me learn how to build amps, so that's a good thing. I've had the parts for this for almost 3 years, and it took me almost a month to put it all together. Had some difficulty with the chassis. I was going to reuse an old one, and that didn't work out, so I made a new one. And then I drilled it wrong, had to start over again. So that's the third chassis for the amp. The chassis is the metal case. Everything else has gone pretty smooth. The biggest problem that I had with this was taking my time. Every problem that I had, every issue, was just me getting ahead of myself and not doing what I was supposed to do. So what we're getting ready to do here is power it up for the very first time. I finished all of the wiring last night. And I could have done all of this then, but I have two rules. One, when it's after 9 o'clock and it's time to watch Dexter with the wife, it's time to put the amp away. And the second rule is when you're ready to go to the next stage, you got to walk away from it and just think about what comes next. Everything that you see here, as it sits, is benign, but the second I apply power to it, we're going to have voltages, some of them over 400 volts, and you just don't want to do the wrong thing. So walk away from the project, have a cup of coffee, work a day, and then come home and do it all over again. So we're going to turn everything on. I'm going to verify the voltages at certain spots against published data off of the plans that they provided me, and see how they compare. Safety first, I'm wearing my rubber-soled shoes. I'm standing on a thick rubber mat. I'm going to do pretty much everything that I do here with one hand in my pocket. That way I don't, if I happen to ground myself out, the electricity doesn't have a path across my heart. Hopefully it'll just go down to my feet and make me hurt a little bit. But let's hope that that doesn't happen. Backing up here, this is another a good reason why I like to walk away from a project. I use some of that time to clean up the workbench. From the pictures you've seen before, there's tools and crap all over the place, but now it's pretty clean. As I was cleaning up, I found this stray resistor that is supposed to go in the amplifier. And turning it on without that probably wouldn't have caused any problems, but you never know. Anyway, it turns out that this was from a feature of the amp that I omitted. I don't need this part, but it just goes to show you can't be too careful. You always find stuff. So enough of me talking. Let's get this going. I've got a setup here. It's called a current limiter. It consists of two 120 volt receptacles wired in series and a 100-watt light bulb. What happens is the electricity will flow through this setup, and if there's a short in the amplifier, the light bulb limits the current so that it can't run away and get hot and blow up. It's going to do a couple of things for me. The very first thing it's going to do is tell me whether I have a short in the circuit that's already there. When I apply power, the light bulb should light up and then go very dim again, if not off completely. As long as the light is off, everything is good to go. If the light comes on and stays on, and especially if it burns bright, that's bad. We got to shut power down. I'm tied in remotely. I'm not going to be touching the case at all when I actually flip the power switch on for the first time. Everything's going to be done from over here well away. So here's the power cord. I'm going to plug this in now because I'm going to use it later. Okay. Now you look up here, we have two power switches. One is for the main power, another is for a feature called standby. What happens is tubes won't conduct electricity unless they're hot. There's a filament in there, it's called a heater. It heats up the cathode of the tube and it boils electrons off of it. Once the electrons are in this glass envelope and everything's nice and hot, they'll flow as long as current is flowing. So we're going to leave it on standby and flip this main power switch here as if we were turning the amp on. And then I'm going to come over here, I'm going to watch my light, and I'm going to watch the amp. The amp turned on, the light stayed off, and I'm just going to stand here and watch for smoke, sparks. And I don't see any. I think we're good to go. Next thing I'm going to look for is to see that these tubes are lighting up. You can see the glow in the tube, this orange glow right here. That's that heater filament heating up the cathode on the power tube. We have a light here. That's the first preamp tube. And down here, very dim but present, is power here. So I have my heater circuit is good. Everything is working as it's supposed to. I also want to keep an eye on this and make sure that these plates don't start to glow too hot. They will get orange, but I don't want them glowing real hot. I have to do a procedure later called biasing to make sure that the voltage in there is correct. But for now, we're just going to leave it as is. So good to go so far. Next thing I'm going to do is I'm going to start checking voltages. Use my handy digital meter here, set for DC volts. And the first thing I'm looking for is roughly 382 volts at the B+ junction, which is right here. Well, that's not going to work because I haven't taken it out of standby yet. So, here goes nothing. Stand back a little. Right now we have full voltage applied to the entire circuit. Still no smoke, no funny smells, no fire. And I should be getting the voltage I'm looking for now. $372, that's close enough. It's only about 10 volts off, and we have a current limiter, so. B+2, I'm looking for 371. And that is right here. I'm not getting the voltage I'm looking for. It's way low, it's in the minuses. Let's keep going and see what happens. Getting some strange voltages. So that means something's not right. Okay, well, something ain't right, so time to shut down, and I'll see you when things are right. Okay, we're back. Found the problem. I'm almost ashamed to admit it, just in case somebody who knows what they're doing actually ever watches this. I had to add this little red wire here. When I made all of the underboard connections, I left this out. This is the first filter capacitor in the power supply. Voltage got to here and never made it any farther. It has to go to this junction here through this resistor to the rest of the circuit. So, easy fix. I'd actually kind of guessed that might be what the problem was. If I'm getting power here and no power anywhere else, then there's got to be a break here. Luckily it wasn't a break, something that I would have had to take the whole circuit board out and fix from underneath. I added that wire and we should be good to go. So I'm going to start it up again, same procedure as before. Current limiter in, remote power is off. I'm going to turn this switch on here. And the amp powers up. The current limiter, the light stays off. That's good. The tubes are lighting up. Never had a problem there before. No smoke, no flame, no sparks. Always a good sign. And we're back to checking voltages. I wanted 382 right here. And I'm getting nothing because, once again, it's in standby. God save me from myself. Full voltage applied.
You got a dim light.
Got 279 here now. 280. It's a little low. What was that? Was it the snare? It's a little low, but the rest of the circuit has taken some voltage, so I didn't expect to see that drop, but I know why it's there, not a big deal. Next point, I'm looking for 371. Here. It's about 100 volts low. That's okay for now. At least I'm seeing something better. The bulb is coming up, but it's dim. It's still dim. So as these heat up and start drawing current, we're going to see a little bit of action there. But as long as it's not glowing brightly, I'm still good to go. Everything seems to be just about 100 volts low. Alright. I'm going to power down and remove the current limiter and see what happens. There we go. Still a little low, but right up there. Much better. typically about 30 volts short of what the published data is. The published data and my actual readings aren't necessarily going to match. And that's not bad. At least it's up in the 300 range now. Checked all the voltages, everything's good to go. I'm getting power where I'm supposed to be getting it, and it's within a range that's acceptable. Seems a little low versus the published data, but that could be a lot of things. It could be the power coming from the wall, it could be the efficiency of the capacitors, or the fact that the tubes are new and they need to be burned in. There's a lot of different things. The amp will function as it's supposed to, and it'll sound great, I'm positive. But right now what I want to do is I want to check the bias on this power tube. Biasing ensures that the correct amount of current flows across the plates. If it's too hot, it works it harder, it wears the tube out faster, and it gives you an unpleasant sound. If there's not enough current flowing, it sounds thin and cold, and again it causes wear and tear on the tube. So what I want to do, I have an adjustment here. Okay, let's get going. Here's how we do that. There's a mechanical method. It's called the current cathode, or the cathode current method. You have to install an additional resistor, measure across the terminals, and divide that by your mother's shoe size and what phase of the moon you were born in, and that gives you your correct plate current. But I'm going to use a method a little bit different that's just as accurate and will tell me what I want to do, and it's a visual representation. You have the speaker output here plugged into a dummy load over here. There's a series of resistors in there. I don't want to run it without a speaker, so it's going into the dummy load. The dummy load is hooked up to the oscilloscope, because everybody and their brother asked me, what do you use that thing for? This is one of the things that I use it for. We're going to apply a signal to the input of the amplifier. I'm going to use this handy dandy signal generator that I built. Turn that down a little bit. And turn that down a little bit. Okay. Can you get a shot of that? You see the waveform here. We want a nice clean waveform, but this has got a notch in it, and that's called the crossover notch. That means that I've got too much or too little current. I don't know just yet, but I'm going to adjust this potentiometer here, and we're going to try and eliminate that crossover notch. Okay, that appears to make it worse. So the thing is to get that notch to disappear, or to go away the best I can get it. And so far, that's about it. That looks good. Later on I'll go back in and do the cathode current method and get the numbers right, but I think I've done enough farting around. Let's plug a speaker in and make some noise. not loud enough. It's supposed to be 20 watts. It should be pretty loud. Renee should be poking her fingers in her ears. I got a couple ideas about why. Damn, it sounds good. Love it. Thanks for putting up with me.